Record. Perfect. Hello, this is our CS660 final project, and the main topic of our project is spatio-temporal analytics of city bike trips. So, the group members are Kennedy and me, Sean Thomas. So, let me give you an overview of our project. So, our goals were to compare how members versus casual riders use bikes on a day-to-day basis within the city. And there are a lot of bike stations where you can pick up your bikes and ride from one station to another. So our aim was to find out which stations are the most important. Our goals were also to map out the coverage areas where people with bikes were able to cover what kind of distances and what areas they were able to cover. And we were able to also understand when people ride the most, what time of the day they are using these bikes. So let me give an overview of the data. So the data we used was the 2 months of city bike data. City bike data is millions of bike trips in New York City. It includes start and end times, start and end stations, trip duration, user type, and demographics of the user if they are available. So this data is really good to analyze riding patterns, station usage, and demand trends. So we actually had 3 months of city bike data, but it was taking a lot of time to load in 3 months of data. So we switched to loading in 2 months of data. And like I said, it's the New York City bike share system, has millions of individual bike trips, along with complete trip details and locations. So we performed the four main tasks in this, which were map reduce, Spark processing, network analysis, and map analysis. Using reduce, we were able to find the busiest routes and peak times. Using Spark processing, we handle massive data sets efficiently, like because this New York data set was extremely large, and to process it, we required Spark. Network analysis, where we were able to identify the most connected stations where people use their bikes to and fro from these stations. We also were able to perform map analysis, where we measure coverage areas and distances.
Hi everyone, this is Kennedy. What we discovered is the members in casual riders are completely different. The behaviors diverges by time and space, and members show strong commute peaks, especially between 5 p.m. to 6 p.m. And morning peaks around 8 to 9 p.m., 9 a.m. The casual riders have a midday to late afternoon build and the smaller peaks at 5 p.m. to 6 p.m. as well. Especially the member context how is broader, which is consistent with commuting reach, while the casual how concentrate around leisure or destination hours areas. Hourly how areas expand during peak for the members, especially showing citywide reach at rush hours. Next slide, please. For which station matter the most? From the top page, we see dominant flows flowing clear corridors. Page rank stations by how much important flow leads into them, and not just the degree. The top tier station coincides with major connectors or transit adjacent hubs, which mean there will be rebalancing and capacity planning. Triangles and clustering highlight neighborhoods with dense local circulation loops, suggesting zones where the short route trips are common. Also, we discovered that the top 10 stations save areas within a 300-meter walking distance. Next slide, please. The real-world impact. After we have done the project, we then find out that these are the impacts of the real-world based on what we have analyzed the data and done. Operationally, this suggests we focus on rebalancing near high page rank hubs during peak windows, which means we use 300-meter buffer union around top star stations as a covered metric for accessibility, expand or densify where gaps persist. We treat member versus casual footprint differently for the commuter corridors versus the leisure clusters. We can also add new steps where we can add the weather or events, try commodity detection and scale the partial pipeline fully in Sodora. Next slide, please. This is the end of the presentation. Thank you.
Yep. So this is all from our side. Thank you for listening to our presentation.